Good day, everyone. I'm Arvin S. Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss one-to-one functions under your General Mathematics from Quarter 1, Module 11. Our lesson objectives. At the end of this video lesson, you are expected to first, determine if a function is a one-to-one. Second, identify real-life situation using one-to-one function. Let's deal now with the definition of a one-to-one functions. So the function f is a one-to-one if for any x sub 1 and x sub 2 in the domain of f, meaning to say that your x sub 1 and x sub 2 are values of your domain of this function, then f of x sub 1, or the function with respect to your x sub 1, is not equal to your f of x sub 2, which is your function with respect to your second value of your domain. So these x sub 1 and x sub 2 are independent variables. So these are x values that pertains to your domain. Now, that is the same y value is never paired with two different x values. So, in a simple word or words, no, this definition of one-to-one function uh, tells us, no, that one value of x can provide you only one value of y, or there is only one value of input, no? If we put a value of x, because your x variables or your domain will serve as an input. If we put a value on it, then it will provide you only one value of y. So there is no such thing that a one value of x can provide you two or more values of y. The same thing with your y. There is no such thing. If we put a value of y, then it can provide you two or more values of x. So from the word one-to-one functions, there is only one value of x that can provide you only one value of y. Or each of the value in your domain or x variable will be partnered to only one, no, y value. So if there is a given set of ordered pair, for example, and this set of ordered pairs, no, represent a one-to-one function, then there is no repetition in your x values and your y values, meaning to say that there is a one-to-one relationship between your two variables involved, and that is your x variable and your y variable that represent your domain and range, and or your independent and dependent variables. Again, when we say one-to-one from the word or words of one-to-one, no? One value of x can provide you only one value of y, or vice versa. That one value of y can provide you only one value of x. There is no such thing, no, that there is a repetition in your x um, values and your y values. Each of the x values, no, will be factored to only one value of y. So it's a one-to-one relationship between your x and y variable. So that is your one-to-one function. So let's now examine these two figures. So your first figure is a Venn diagram of a one-to-one function. Your second figure is a Venn diagram of a function that is not a one-to-one. So there are situations no wherein your Venn diagram represents a function but not a one-to-one function. But let's deal now with your figure number 1 before dealing with your figure number 2. In your figure number 1, no, I said a while ago that this is a Venn diagram of a one-to-one function. So as you can see in these values of x, this will serve as your x or your domain. This will serve as a value of your y or your range. So this x will be your independent variable and your y will be your dependent variable. So as you can see in the values no under your x or your domain, there is no such thing as repetition of values. So we start from -3, -1, 0, 1, and 5. So meaning to say that there is no repetition in your x values from your figure number 1. While in your range no or y values, we start no from 0, 1, 2, 4, and 3. Again, if you try to observe and assess these values of y, so there is no such thing as repetition no in your y values. And each of the value under your domain or independent variable here will be partnered to only one value of your dependent variable, which is your y. Your -3 will be partnered to 0, then -1 will be partnered to 1, then 0 will be partnered to 2, then 1 will be partnered to 4, and 5 will be partnered to +3. So this diagram or Venn diagram no represent a one-to-one function because again no if you try to observe the values in your x and your y, there is no repetition of values under these two variables involved, and each of the value of x no will be factored to only one value of y. So there is a one-to-one relationship between your x and y variables. Now, dealing with your figure number 2. So it is a Venn diagram of a function. So we consider this one as a function. Why? Because a function, no, as long that there is no repetition in your x value here, then we consider that this Venn diagram is a function. But again, it is not a one-to-one function. Why? Because if you try to observe these two values of x here, -1 and 0, so these two independent variable values no, from your domain and or your x no, and this will be your y from these values no, there are two values of x that can provide you only one value of y. This -1 and 0 can provide you the same value of y, which is +2 here. So meaning to say, if we try to isolate this one, no, if we try to convert this Venn diagram to a set of ordered pairs, this -1 will be partnered to 2 and 0 will be partnered to 2. It's the same thing with your -1 and 2, meaning to say that there is a repetition in your y values. So based on the definition of a one-to-one function, there is no such thing that two values of your domain can be partnered to your one value of y. It should be one-to-one relationship between your x and y variables. So in this case, no, still this Venn diagram is a function because your function can be one-to-one, no, one-to-one, one-to-one here, no, and it can be many to 1. So it can be 1 to 1 again, no? Your function can be 1 to 1 and many to 1. So these negative 1 and 0 and 2 represent a many to 1. That's why still, no? When we try to look at a Venn diagram, still it is a function. Why? Because there is no repetition of values in your x. But in this case, no, when you're dealing with your one-to-one function, we cannot consider this Venn diagram as a one-to-one function because there is a repetition, no, in your y values. If we isolate negative 1, 0, uh, that will be partnered to your positive 2. So it's negative 1 and 2 and 0 and 2, meaning to say that there is a repetition in your y values. That's why still, even if no, this diagram is a function, we cannot consider this one as a one-to-one function because a one-to-one function represent that there is only one value of your input x, no, that can provide you or that can give you only one value of your output, which is your y. So, meaning to say, it's a one-to-one relationship, no, between your x and y variables. So, with this one, no, so we're asked to determine whether the given relation is a function. If it is a function, determine whether it is a one-to-one function. Now, for number 1, the relation fairing no, an SSS member to his or her SSS number. So there are two variables that will be your SSS member and the SSS number. So as we know, no, that each SSS member assigned a unique SSS number. Meaning to say that there is only one SSS number to each SSS member. So there is a one-to-one relationship. So there is no such thing that we can give two SSS members, no, with the same SSS number. Or or we can give SSS number to 3 or 2 or more SSS members. So there is no such thing like that, no? Meaning to say that each of the SSS member will receive a unique SSS number. So there is a one-to-one relationship between your SSS member and SSS number. No? Thus, the relation is a function. No? So, two different members cannot be assigned the same SSS number. So, that's the reason. Because we cannot assign uh, one SSS number to two or more SSS member. We can only assign one SSS number to each SSS member. So, there is a unique SSS number that each SSS member will receive, no, from SSS. So thus, the function is a one-to-one function because there is a one-to-one relationship, no, between your SSS member and your SSS number. Now, for number 2, the number 2, the relation pairing a citizenship to a person. So your variable here is your citizenship and a person. Now, so the relation is not a function. Why? No? Because a person can have dual citizenship. No? Meaning to say that citizenship is not unique because even you are a Filipino, no? Even your citizenship is a Filipino, then you can apply for American citizenship. Then you can have no this dual citizenship. Again, if we're talking about citizenship, we have the right to have no two citizenship. That's why this citizenship is not a unique, meaning to say that there is a many to one relationship. So it can be Filipino and American to a person, or one person to a Filipino and American citizenship. Now, in that case, no, this number two is a relation, no? It can be a function, but not a one-to-one function. Why? Because citizenship is not a unique. Because each of us, no, have the right to have no dual citizenship. For number three, so the relation pairing a real number to its square. So when we say real numbers, no, or real number, these are negative numbers, positive numbers, including zero. So negative 1 and positive 1 can be considered as a real numbers. It is right, no? Negative 1 and positive 1 are real numbers. Now, if we take the square of negative 1 and positive 1, then it can provide you the same value, which is positive 1. Because negative 1 multiplied by negative 1, no? It's positive 1. Positive 1 multiplied by positive 1, it's positive 1. Therefore, no? This uh, number 3, no, is not a one-to-one function. So, because any reason, what is the reason, no? Because each real number has a unique perfect square. Thus, the relation is a function. Still, it is a function, no? However, no, two different real numbers such as negative 1 and positive 1, no, may have the same square. Because if we take as the square of this negative 1, it can provide you a positive 1. The same thing if we squared positive 1, no? It can provide you the same value once we square your negative 1, which is your positive 1. Therefore, there is a repetition, no? Uh, there is a repetition of values that can provide you only one value of an output. So if we input negative 1 and positive 1 and we take the square of these two numbers, then it can provide you a positive 1. It's the same value. Meaning to say that there is no one-to-one relationship between this real number and to its square. The only reason that each real number has a unique perfect square. But there are situations wherein, no, wherein at some point, if we take a square of a negative number with the same absolute value to a positive number, it can provide you only one value of output. So that's the scenario that we cannot consider this number 3 as a one-to-one function. Why? Because there is a repetition in your input. We can consider this one as a relation and a function, but not a one-to-one function. For number 4, no, the relation pairing an airport to its airport code. No? So there are two variables here, your airport and your airport code. So the relation, no, pairing an airport to its airport code, no. When we say airport code, these are MNL. For example, MNL. Uh, I mean, NAIA. So this NAIA stands for Ninoy Aquino International Airport. CEB stands for Mactan Cebu International Airport. No, so these are there are three. No, there are three letters that we can use for this one as an airport code. No, for example, Ninoy Aquino International Airport, we use M and L. Then CEB for Mactan Cebu International Airport. DVO for Francisco Bangoy International Airport. JFK for John F. Kennedy International Airport. No? So airport codes are three-letter codes. No? Used to uniquely identify airports around the world and prominently displayed on check-in bags to denote the destination of these bags. So meaning to say that there is a one-to-one relationship, no, between your airport code and your airport. So there is no such thing that we can use an airport code, no, for other airport. We can only use one airport code to a one airport. So we cannot use, I said a while ago, no, for example, we cannot use CEB as an airport code for NAIA because MNL it is designed for NAIA. So there is no such thing that we can put another airport code for NAIA because there is a one-to-one relationship, no, between your airport and your airport code. So therefore, your number 4 now, no, is a one-to-one function. Why? Because since each airport has a unique airport code, then the relation is a function. First thing to do, we consider this number 4 as a function. Also, no, since no two airports share the same airport code, then the function is a one-to-one function. So there is only one airport code designed for an airport. So it's a one-to-one relationship between your airport and your airport code. Meaning to say that number 4 is a one-to-one relation. Or it's a one-to-one function. Or it represents a one-to-one function. So for number 5, so the relation pairing a distance d in kilometers traveled along a given jeepney route to the jeepney fare for traveling that distance. So as you can see, no, the relation, no, is a function. Since each distance, no, traveled along a given jeepney route has an official fare. So for example, 8 pesos, no, for the first 4 kilometers. Additional 2 pesos from the exceeding from if we exceed to 4 kilometers. So there's an additional uh, 2 pesos in each if we exceed to 4 kilometers. Therefore, there is an official rate for each of the route, no, of this jeepney. So in fact, no, uh, this scenario, we discussed this scenario from your piecewise function. that the jeepney fare may be represented by a piecewise function. So this scenario can be represented by a piecewise function. So there are two functions that we can use this to represent this scenario. No, we can take note. No, please do take note that this D is the floor function applied to D. No, this D is the floor function applied to your distance. That this absolute value of D is the floor function applied to your distance. So in this case, no, if the distance to be traveled, for example, is 3 kilometers, for example, then we can use f of 3, that we input 3 as a value of your D. So your f now with respect to your 3 is equal to 8. For example, if you travel 3 kilometers, then your fare is 8. So what will be the function now that will represent uh, your fare, no? Or the minimum fare for this one, 3 kilometers. So that will be 8 pesos. So if we input this 3 to your function, then it must be from it must be equal to 8. No. However, no, the function is not a one-to-one function because different distances. For example, no, because of the different distances, still, for example, if you travel 1 kilometer, 2 kilometers, 3 kilometers, still your minimum fare is 8 pesos. So you will pay 8 pesos even if you travel only 1 kilometer, 2 kilometers, no? If you maximize this, if you travel 3 kilometers, still you can pay, no? The jeepney driver with your 8 pesos. Now, be, uh, this function is not a one-to-one function because of different distances. For example, 2, 3, 4 kilometers are charged the same rate, which is your 8 pesos. So that is the scenario now. That is because f of 3 is equal to f of 2 and f of 3.5, for example, is equal to 8. No, if your x represent the distance or your d represent your distance, if we input a value on your distance from 1 to 4, still it can provide you the same value of f or the function that will represent your fare, no? Because it is a minimum fare. So whether you traveled 1, 2, 3, or 4 kilometers, once they set, no, 8 pesos for the first 4 kilometers, even you travel only 0.5 kilometer, still you need to pay 8 pesos. That's why this number 5 is not a one-to-one function. So graph of a one-to-one function. So let's deal with the graph of a one-to-one function. So if f is a one-to-one function, then no two point x sub 1, y sub 1, and x sub 2, and y sub 2. No 2 points, meaning to say that there is no such thing as point of intersection, two or more point of intersection uh, with the same y values, no? Have the same y value. Meaning to say, if we try to look for a graph of a one-to-one function, you need to satisfy that there is no points x sub 1, y sub 1 with the coordinate of x sub 1, y sub 1, x sub 2, and y sub 2 have the same y value. So there is no such thing as the same y value in your graph. For example, if we consider this point 1, point 2, dealing with your one-to-one function, there is no such thing as y sub 1 is equal to y sub 2. So that will be an error. It should be y sub 1 is not equal to your y sub 2. So there is no such thing as repetition of y value in a one-to-one function. The same thing with your x, no? Therefore, no horizontal line cuts the graph of the equation of y is equal to f of x more than once, Meaning to say, once you're dealing with a one-to-one function, there is no such thing, no, as point of intersections, no, more than one between your horizontal line and your graph. So example, compare the graph of the above functions, no. So with your first graph here, no, this will be your first graph. So if we apply your horizontal line test, as you can see, there is only one point of intersection between your horizontal line and your graph, which is your line that rises from left to right. So again, even if we apply here your vertical horizontal line test, then there is only one point of intersection. As long that there is a only one point of intersection between your horizontal line that we applied to your graph, no, if this horizontal line cuts no, the graph only once, no, then this graph represents a one-to-one function. So we need to satisfy that your horizontal line test will pass through or through your graph only once, meaning to say that there is only one point of intersection between your uh, horizontal line and your graph. So in your second graph here, no, in your second graph here, so if we apply your vertical line here, as you can see, there are 2 point of intersections, no? So it is a function. Why? It is a function, but not a one-to-one function. So not a one-to-one function. Why? If we apply vertical line test, we satisfy that there is only one point of intersection between your vertical line and your graph. Therefore, we can conclude that this graph is a function. But again, we need to satisfy your horizontal line test. So if we apply your horizontal line test here, no, there are 2 points of intersection between your parabola that opens upward, no. There are 2 points of intersection between your horizontal line and your parabola that opens upward. Meaning to say, even if we satisfy your vertical line test, still this graph is not a one-to-one function. It is a function, but not a one-to-one function. In a simple word, no, in dealing with the graph of one-to-one function, you need to satisfy both your horizontal and your vertical line test. Your horizontal, your vertical line test can be used to identify, no, if the graph is represent a function. But again, we really need to make sure that we satisfy your horizontal line test because it proves, no, that this graph, no, once we satisfy this horizontal and vertical line test, then we can conclude that this graph is a one-to-one or it represents a one-to-one function. So here is the formal definition of a horizontal line test. So a function is a one-to-one if each horizontal line test does not intersect the graph at more than one point. Again, no, once you're dealing with a one-to-one function, there is only one point of intersection between your horizontal line that you're going to apply, no, in your graph. There should be, or there's only one point of intersection, no, between your horizontal line and your graph before we conclude that your graph is a one-to-one function or it represents a one-to-one function. Now, you really need to take note of this, no? The vertical line, the vertical and your horizontal line test. All functions satisfy the vertical line test. Yes, it is, no? Because that will be our basis, no? If we satisfy your vertical line test, automatic that your graph is a function. But again, for us to check if that is a one-to-one function, then we need to apply your horizontal line test. All one-to-one functions satisfy both the vertical and horizontal line test. So that's what I'm talking about a while ago, no? That once you're dealing, or if you're asked to determine, no, if the given graphs, no, represent a one-to-one function, you really need to apply your vertical and horizontal line test. Because if you satisfy only your vertical line test, then the graph is not a one-to-one function. So it should be a combination of vertical and horizontal line tests. So there is no such thing as a one-to-one function that you only satisfy horizontal line tests. You need to satisfy both your horizontal and vertical line tests before you conclude that these graphs, no, represent a one-to-one function. So if you if you're not if you can't satisfy, no, these two line tests, then you cannot conclude that these graphs or the given graphs, no, represent a one-to-one function. Again, if you're dealing with a one-to-one function, you need to satisfy both the vertical and your horizontal line tests. So, we're dealing with these four graphs, no? Which of the following graph shows one-to-one functions? So let's put here f that will represent your function, so we can have your checklist, no, in dealing with these four graphs. So function f for function, then one to one f here that will represent a one-to-one function, because there are functions wherein there are graphs, no, that represent a function, but we cannot consider them as a one-to-one function. So let's deal with these four graphs here. Let's identify if they are a function or at the same time they are a one-to-one function. For the first graph, no, once we apply your vertical line here, no, there is only one point of intersection between your vertical line and your graph. So meaning to say it is a function. So the graph is a function. Let's check. If we apply horizontal line here, there is only one point of intersection between your horizontal line and your graph. Let's try in this portion. If we apply horizontal line, there is only one point of intersection between your uh, horizontal line and your graph, meaning to say that this graph represents a function. At the same time, it is a one-to-one function because you satisfy both your horizontal and vertical line test. So for graph B, let's try if it represents a function. So if we apply vertical line here, so there is only one point of intersection. Let's try it at some point here. At some point here, when we apply vertical line, so there is only one point of intersection between your vertical line and horizontal and your graph. Then this graph is a function. So let's check if this is a one-to-one function. So if we apply your horizontal here, line test here, then there are 4 point of intersections, no, between your horizontal line and your graph. Meaning to say this graph B is a function but not a one-to-one function because there are 4 point of intersection. Once we apply your horizontal line here in this portion, then it provides us, no, 4 point of intersection between your horizontal line and your graph. For graph C, let's check. Let's apply your vertical line test first. Let's apply your vertical line. So if we apply your vertical line, there is only one point of intersection between your graph and your vertical line. Let's try at some point here. So once we apply your vertical line, there is only one point of intersection between your vertical line and your graph. Therefore, this graph represents a function. Once we apply your horizontal line here, no, there are 2 point of intersections between your horizontal line and your graph. meaning say it's automatic that this graph represents a function, but not a one-to-one function. It is a function, yes, it is, because you satisfied no your vertical line test. But again, you did not satisfy no your horizontal line test. So before we conclude that a graph is a one-to-one function, no, then we need to satisfy both your horizontal and vertical line test. So in graph D, no, if we apply vertical line here, there's only one point of intersection between your vertical and your graph. Therefore, it is a function. Same thing with once we apply at some point here, there is only one point of intersection between your graph and your vertical line. So we can conclude now that this graph represents a function. Now, if we apply a horizontal line here, so there are two point of intersections between your horizontal line and your graph. So meaning to say, this graph represents a function but not a one-to-one function. No? So it represents a function, I mean, but not a one-to-one function. Again, dealing with these graphs, you need to satisfy both your vertical and your horizontal line test before we conclude, no, that this graph represent a one-to-one function. So there is no such thing that we satisfy your vertical line, then we conclude that this is a one-to-one function. Again, you need to satisfy both your vertical and your horizontal line test before you conclude that these graphs represent a one-to-one function. Because most of the graphs can be a function. Yes, it is, no? Because you can satisfy vertical line test. But again, dealing with one-to-one, you need to satisfy both your horizontal and vertical line tests. So for your activity, so identify whether the following represent one-to-one function. So your answer will be one-to-one function or not one-to-one function. So there are two answers here, no? It can be one-to-one function or not one-to-one functions only, no? For first statement, degree Fahrenheit to its equivalent degree Celsius measurement. Is it one-to-one or not? Number two, person to his or her citizenship. It is a one-to-one or not? Number three, fare to the distance traveled. Is it one-to-one or not? Number four, cell phone to its cell phone number. Number five, length in meters to its length in inches. Number six, father to his first biological son. ATM card number to account name. And 8, person to his favorite music. 9, house to the telephone number. 10, brand name to pair of shoes. No. So there are there are 10 statements here, and you're asked to identify whether the following represents a one-to-one function. Again, your answer can be one-to-one or not one-to-one only. Thanks for watching. Please like, comment, and subscribe.